Welcome to another episode of Space in Africa's webinar series titled Feeding Africa, the role of satellite data for food insecurity in Africa. My name is Mustafa Iderawumi. I'm a senior analyst at Space in Africa, and I'm truly honored to be your host today. You'll all agree with me that inhabitants in different African regions continue to struggle with the threats of food insecurity. And this is caused by a variation of factors, which includes poor agricultural processes, climate change, political instability, and several other factors. So it then came as no surprise when an analysis done by Relief Web noted that around 282 million Africans, which is around 20% of the entire African population, are undernourished and also unable to afford healthy diets. So our discussion today would focus on insights into Africa's food security challenges. We would also look at how Africa and Africans are utilizing space technology to address this particular issue. Then we would also look at some of the innovative solutions that have been developed using Earth observation technologies for food security in Africa. But first, let me introduce our esteemed panel of speakers for today. With me, I have Laura Bodnant. She's a geospatial analyst at World Food Program. I also have Edward Boma. He's a technical manager at Digital Earth Africa. And last but not least, I have Stephen Corey. He's a geospatial data scientist at Amini. But before we go into the discussion properly, let me give you a quick rundown of today's agenda. So first, I'm going to direct some questions to our speakers that will drive conversations into different thematic areas. And after that, we are going to take some questions from the audience. Also, before we begin, let me also say a very big thank you for everyone that has joined us on today's program. And just like I mentioned, as we progress into this event, if you have questions, if you have comments at any point in time, please drop it in the chat box and we'll take as much as we can during the Q&A section. So to start us off this afternoon, Edward, my first question would go to you. So I think the best place to start is to do like a brief overview of the current state of food security in Africa. And if I can also highlight to us what those challenges are that needs to be addressed. Thank you.
Thank you, Mustafa, for having me here to talk on this subject. So currently, many African countries have large proportions of the populations living in rural areas, and they are mostly engaged in agriculture. But whatever they are producing, they produce it at least some food that will actually cater for their family within those areas. And this is actually a challenge and an opportunity. What it means is that a lot of people are exposed to climate risks, but it also means a lot of people can benefit from advancements in agriculture and also the environmental practices that we are facing. And within this challenge, I'm actually moving towards the Earth observation area, whereby the Earth observation technology can actually aid in providing real-time data on weather patterns, crop health, and land use. Because the challenges that we are facing currently, not just for one country, but a whole lot of countries, and having this report there. So having food insecurity happening around that area actually poses a lot of challenges for them. So having Earth observation available can actually help us to work on address on some of these challenges. And to make an example, I'll talk about early warning systems that Earth observation can actually help us to provide information on, such as natural disaster, supporting precision agriculture, also for optimal resource management, and thereby enhancing monitoring of distribution and market access. So although the challenges are there and there's no way that all of us are in it, for us to be able to do that, looking at the Earth observation technology area can actually help us to be able to overcome the current state of the food insecurity problems you are having in Africa. Thank you.
Thank you very much for that brief overview. So Laura, I'm going to pose the next question to you. So I know that World Food Program have a lot of areas where they, where they develop and implement solutions. But I want to talk majorly on the West African area. So can you discuss with us any specific projects or programs that you've been involved in, which aim to maybe reduce the region's food insecurity?
Okay. Yes, thanks for the question and thank you for the invite. I'm gonna present myself very briefly just to explain that, yeah, I've been working with the World Food Program, now working with Haiti country office, but I used to, before several years in the Sahel. And between 2019 and 2022, 23, yeah, I focused more specifically on the projects involving Earth observation imagery to observe hard-to-reach areas. The first country where we implemented it was in Mali, where I was based in Bamako in the beginning, to kind of understand what was going on in hard-to-reach areas. So in that period, there was in the central region of Mopti, and it all started for just a few localities where it was an actual like black box of information. It was really hard to have access due to security restrictions, and so there was very, very little data, and we started to think of using satellite imagery to kind of observe what would be the impacts that we could possibly see on livelihoods in link of insecurity, like conflict and violence that we knew was occurring in the area. So we used Sentinel-2 imagery, and what was actually very clear, it was that in some localities, there was a very visible impact of that insecurity on farming activities. So people stopped cultivating in specific localities, not all of them. And so then we expanded this project, this tool that we were developing to 100 villages and then to the whole region of Mopti to kind of highlight areas where there was a severe agricultural decline. And then we thought it was interesting to go that deep in the information because Sentinel-2 is a high resolution imagery, so it allows us to go and grab information at locality level, which is not like usually we have information and data at admin 2 level, maybe sometimes at admin 3. That's usually the best we can do, but at locality level really helps organize the response and better target the emergency response of WFP. So this is one example of a project that we worked on involving satellite imagery, and that we then kind of scaled up to other areas in the Sahel and in the region with similar challenges and problematics. So yeah, that's it for me if you have further questions.
Yeah, I'm going to ask you like the further question on that, but first, let me also get Stephen's view on a particular subject. Stephen, a lot has been said about AI and how that can be used in different sectors of the industry. So I wanted to just talk briefly about the role that remote sensing or EO data, together with artificial intelligence technology, play in monitoring and improving food security in Africa.
Thank you so much, Mustafa. It's an honor being here today. So let me talk about the role of remote sensing in food security. So first, when you look at food security in itself, you just have to look at the security bit of it. So what do we mean when we say food security? We want to ensure that whichever locality you are in, whichever you're in, we want to ensure that you have enough food. I mean, it's among the SDGs, that we end hunger. So we have to ensure that we have enough food to feed the people. Now, remote sensing in all this is, first of all, before the Earth observation in these, we used to use observational techniques and statistics to try and quantify the amount of food that we have in a certain locality. But now with the advent of observation, it becomes a bit easy to quantify the amount of food, let me say crops that we have in a certain location, because with the advantage of satellite imagery or Earth observation, we are able to create some machine learning models that can be able to help us do what we call crop type detection. So we are able to discriminate between the different types of crops that are grown in a certain region. The moment we are able to discriminate between the different crops, then we do what we call crop yield estimation or or prediction. You know, when you do the estimation bit and you already have the crop types, so easy for you now to understand how much in production do we have as a county or as an admin tool, or, you know, those different administrative boundaries. Then there, as a country, how much do we consume? You know, so when having all these, you know, statistics with the help of Earth observation, then we are able to know as a country, do we have a deficit or do we have a surplus? So it now boils down to what we call a regional food balance sheet, so that we're able to understand in terms of food security, where are we in a position to, do we have a surplus so that we can be able, you know, to give out the surplus, or are we in debt so that we can be able to do something so that we can be able to feed you know, the people. So another thing about the role of remote sensing in food security is about crop monitoring. Earth observation is very easy to do crop monitoring. We're able to crop health from the time that the crop is grown up to the time that the crop is harvested. And in between, if we detect that there are issues with the crop, it spans out from if we detect that we have crop pests and diseases, if we have nutrient deficiencies, then we're able to come up with mitigation strategies. And these mitigation strategies are like fertilizer, putting top dressing fertilizer in crops and all that, you know, and doing what we call target pest application, so that you are able to mitigate these problems that facing because of crop monitoring that has been aided by Earth observation. So we have a lot of, you know, use cases when it comes to the role of the role of remote or Earth observation in food security. As we go on, we'll continue, you know, talking about them. Thank you.
Thank you very much for that. So let me come back to you, Edward. When you spoke the first time, you actually mentioned some areas, and majorly you talked about, you know, the issue of climate change and how that affects, you know, smallholder farmers and other kind of large-scale farmers across different African regions. But I wanted to speak specifically to this particular point now. So we know about the issues or the effects of climate change and what that has on food security in Africa. But what has been proven to be like the most effective strategies for mitigating those effects? Are there strategies like that have been proven?
Yes, actually, there are strategies that has been proven to actually shows how we can mitigate these effects when it actually comes to climate change. One of the strategies that's what we've actually been talking about is the utilizing Earth observation technology. The reason is it actually contributes valuable data and insights that are very essential for understanding and mitigating the impact of climate change on food security in Africa. So let me give an example from the platform of Digital Earth Africa. It actually provides services and products that can actually help us to mitigate these issues. So for instance, you have the NDVI anomaly, the crop marks, fractional cover, and it actually covers the whole of Africa. So if we leverage on these data and integrate them with climate information effectively, stakeholders can make informed decisions to promote sustainable agricultural practices and also enhance resilience to climate variability, and to ensure that food security for a vulnerable population. So one example that happened in Kenya for one of the users that we work with was he was able to integrate these data sets into a mobile app. that farmers can actually use to monitor the climate conditions within the area that they are working. So having this data set is very essential for early warning system, which can actually alert farmers and policymakers for drought, flood, and other extreme weather conditions. And once we're able to have these alerts, they can actually also help us to allow for timely response, such as adjusting the planting schedules. Because mostly if due to drought or due to lack of rainfall, farmers plant and they don't get enough water or rainfall or something due to an issue, it affects the yield. It affects their yield. So having this system will actually help them to also to adjust their planting systems and also implementing water management strategy and activating disaster preparedness plans. And using earth observation technology actually really has actually played a role. I think Stevie Corey will also talk about it. Some of the tools that are there, which has actually been able to help us to monitor vegetation across the African continent, is actually a great thing. So having these technologies, earth observation technologies available, is something that is a best strategy for us to be able to utilize this and help in making decisions across Africa.
Yeah, thank you very much for that. Laura, my next question goes to you. So I wanted to talk about geo-targeting. And maybe before you actually go into the question, I just wanted to do a little bit of overview on what geo-targeting means and how that affects, improving food security in Africa. But the question really goes thus. So what roles does geo-targeting analysis play in assessing food insecurity in Africa? And how can this type of data be used to improve food security interventions?
Okay, great. Thank you for the question. I think so the specific project and tool that I mentioned about derived from Sentinel-2 imagery to highlight cropland abandonment, it was used and integrated in two ways. The first one being to also inform the cadre harmonisé, which is the early warning, the food security, sorry, not early warning, the food security national exercise that are organized in West Africa and Central African countries, not all of them, but most. And so that actually helps to also estimate the number of people in need of assistance. So this is the first step, and it's really important because then it's gonna play a role in how the humanitarian response is organized. And so, yeah, this is the first point. And the second one, as far as I can speak for the World Food Programme, that organizes all year long some emergency responses. It's usually the geographical data is often a very limiting aspect. It's really hard to know exactly where to go and organize the response and organize the distribution, and also what type of response to organize. So this really brought a new level of information. As I said earlier, it was more granular than what we had, but also it helped to, since 2020, in the localities where we detected from Earth observation data that there was a severe or an important cropland abandonment compared to normal years, then the response could be planned and implemented as early as March, which is more or less 3 months ahead of the lean season, the start of the lean season. And so that would also help organize the response in that way. So in terms of timings and kind of focus and target communities that were more at risk because of, farming activities being, in some cases, completely stopped in that specific year. So this is a concrete example of how it has been used. And I think we can, just to give you an order of magnitude, I think in Mali 2020, the WFP, I think it was something like 70,000 people were specifically targeted using those results in an like addition to other information that they have, obviously, but my job was to bring this additional layer of information, I would say.
All right. Thank you for painting that picture for us. And I think, yeah, I totally understand how it works better than I did before you answered the question. Stephen, so my next question will go to you now. It's going to be similar to what I asked Edwards like a few minutes ago. So I just wanted to also highlight some innovative approaches or technologies that you also believe would the most promise for addressing food security issues in Africa. If you can just highlight a couple of them and tell us how they work. Thank you.
Okay, thank you so much. I think some of them have already been, highlighted, talked about, but I can go and talk about them. So the first one is precision farming. I believe that you've heard about precision farming and what precision farming is all about. So precision farming tries to use the available resources at your disposal and optimizing, the resources that you have for better yields. So when it comes to precision farming, how can Earth observation, be used for precision farming? So actually, there are technologies in precision farming that makes it precision farming. So the first thing is, first we need to understand how your soil looks like, because the nutrients in the soil are very key in determining the yields that will come out of the crop that is planted in that specific farm. Determining the soil, the nutrients in the soil or what the soil has is very key. So that is the first step in the precision farming journey. The second one, now you've already planted your farm. You've used GPAG tractors so that you're able to get the dimensions correctly for the specific crop that you're talking about. Now, after the crop has grown, right, you need to start monitoring. So we talked about crop monitoring. So you need to start monitoring your crops, right? But it reaches a point where now you need to apply some mitigation strategies that we talked about earlier. So the second thing that you need to do now, or another technology, is called like variable rate technology. In this, we need to create what is called productivity map. So if you have a farm of 1 hectare, then you need to create what is called a productivity map. This productivity map will be very, very key to understand how your farm is performing, because there is always what you call spatial variability in each farm. The different parts of your farm will not grow at the same rate. Some others will grow differently because of the spatial variability of nutrients. Along the way, probably there were issues of fertilization or leaching. There's slope in your farm, so the nutrients, are going down the slope. We are having a lot of issues in the farm. Pests, we talked about pests and all that. So you need to understand how your farm looks like. Create productivity maps. After you creating productivity maps, you do what is called zoning of those productivity maps, so that you understand which part of your farm has low productivity and which parts have high productivity. Then after that, you do what is called targeted fertilization. Like, the areas that are not performing well. The areas that are not performing well, when you're doing top dressing fertilizer, you're going to target those areas. You're going to apply more fertilizer in those areas than the other areas. Then after that, if the issue in your farm was pesticides or pests, not pesticides, pests or diseases, then you need also to use the productivity map so that you can do what is called targeted pesticide application. So that is a process of precision farming. It involves a lot of activities along the way, but at the end of the day, you will have optimized the resources at your disposal. Another thing when it comes to Earth observation or innovative technologies when it comes to food security is we are now in the age of generative AI. We've heard about language models, and you've seen what they've done. I believe that some of you have used, ChatGPT, Gemini, and all that, and these are products of large language models. Now, in the same veracity, when it comes to food, when it comes to food security, we also have what we call Earth Foundation models. Now, these are models that are trained on very, very large observation data. And they're trained in such a way that they're trained in a self-supervised way where the input data is masked. So they're trained in a self-supervised way so that the model can learn the underlying patterns. And these are always represented as embeddings. And these embeddings now are the ones that will be used for the different, applications or downstream tasks that we're talking about. So earlier I talked about crop type mapping. So the advantage of Earth Foundation models is when you look at the classical crop type detection models, and models are very, very data hungry. They need a lot of training data for you to be able to do to be able to have a training, to be able to have a machine learning model that can be able to do crop type detection. But now when it comes to Earth Foundation models, Earth Foundation models create like generalized models. And these generalized models, you just need to fine tune it a little bit with very little training data so that you're able to get whatever you're looking for. If it is about crop type detection, then you just use very little training data, then you're able to get your crop type maps. So there are a number of other technologies, maybe even extension or e-extension or e-advisory. We know that at the moment in many African countries, we have a very low extension officer to farmer ratio. And now in this era where we're having a climate change and all that, information flow is hindered. So how can we be able to bridge that gap from information to farmer? So the advent of e-extension, and of course, for the e-extension, it needs to be customized to the specific users that you're talking about. Just trying to understand the farmer's profile. If the farmers are able to read, maps on mobile phones, if they're able to, if they're not able to read, what can we do? So we also need to innovate on those areas such that the information that we get from Earth observation data can be able to flow to farmers, and farmers are able to understand and able to apply whatever we are telling them in the day-to-day activities on the farm. Thank you.
Thank you very much for that broad explanation. And before I go to the next round of questions, this is to the audience. If you have any questions regarding whatever has been mentioned today, please kindly drop them in the chat box so we can go through all of that during the Q&A section. So I have a similar question to you, Edward. And so this is just talking about the future of food security in Africa. I mean, we know that it requires multifaceted approach, meaning there are different factors that are going to come into play before that can happen, from the technological side, from the environmental side, from the socioeconomic side, and also from the policy side. So strictly speaking, in terms of what to do at Digital Earth Africa, how do you see the future of food security in Africa vis-a-vis any of these factors?
Okay, so thank you, Mustafa, for the question. So for the future of food security, one of the things that I'm going to talk about is the integration of Digital Earth Africa resources, which actually promises a transformative impact on food security in Africa. Digital Earth Africa actually provides real-time monitoring of crop health, soil moisture, and water resources, which enhances agricultural productivity and resilience to climate change. Right now, you're talking about machine learning. So having predictive models and early warning systems to mitigate risks of crop failure, while data-driven insights optimize supply chain and also inform policy making. Some of the key areas that I think right now we need further development actually includes improving data accessibility and user interfaces so that authorization data set is in the hands of people who need it and can use it. These technologies that we are talking about mostly are in the hands of experts, those who actually understand the system and how it works. So all these data sets and all these systems, platform that I'm talking about, experts are the ones who are using it. But if you try to make it much possible that there are models that has been developed, there are systems that have been developed, but it's in the hands of the people who are actually on the ground, who are using it, will actually be a very nice way to actually help users, especially the local ones, especially the farmers, and those who are into the small scale and large scale farming, to be able to use this platform to make informed decisions. And through that also, not only having the access to the platform makes it like that, because it also requires capacity building among stakeholders, and also investing in infrastructure, and also establishing supporting policies. These three, when they come together, can actually help us to mitigate food security issues around Africa. So collaborative effort is very, very crucial in this area for us to be able to achieve sustainable and equitable food security across the continent. Thank you, Mustafa.
Yeah, thank you. So from Laura, I'm going to give all of you a question that I just want your opinion on. So this is like a very critical aspect to whatever kind of technologies that has been developed or that is being developed, which is the issue of adoption. So it might be an opinion, it might also be like something backed with data, but what do you think about the adoption of EU data analysis, remote sensing technologies, AI, and any other type of technologies in terms of improving food security in Africa? What do you think? Like, what's the current status, if you want to talk about it? And what do you think we need to do to go to the next level? So again, it can be opinion, can be data-based. I just want to know what you think about it.
Okay. Am I going first? Yeah, sorry.
Yeah.
I couldn't hear very well. I'm not sure I got the question right. It's about how we make use of data that comes from the European Commission. Is that it?
So basically, it's just the adoption. So it might be from wherever. So what is the adoption
okay.
of technologies by, the government, or maybe like the people, the end users that actually need them? So what do you think about the adoption?
Well, maybe I don't really adoption, like in the sense that like how people make use and access the data. Sorry, maybe I'm not the best one to answer first. I'm not sure.
Okay, yeah, that's fine. Okay, so let me just go over it again so that I provide more context. So it's in the area of how they receive any kind of data or analysis that you're putting out there. So this is more tilted towards like the government agencies and policymakers and all that. So whatever kind of solution that you're bringing out, how receptive are they to those solutions?
Okay.
Does that make sense now?
Yeah, that makes sense. Sorry
Yeah.
about that. I think there was some like issues with the connection. So yeah, on my end, from my experience, I think so. I had a lot of interactions with the different state actors, either in Mali or Niger, Burkina Faso, and I think every time it was really well received. The idea of integrating more satellite imagery and geospatial derived information. It was more, yeah, I think there was just in the beginning, I remember having a lot of like maybe questions about whether the data is free, how we can access, and then having this whole conversation about how to do the analysis together. And so I think that was the real challenge in the beginning, to kind of make sure everyone was in the same room doing the analysis. And I think then this is what we went towards, and it was really great. I think it was such an it was really interesting, because then there was way more information from like the context, and like rather than just like one analyst sitting in a room and like trying to understand what's going on in Tombouctou, and maybe this is somewhere you've never been. So Yeah, I think in that sense there was a real interest, and more than an interest, there was a really like it was essential for WFP, and I think every humanitarian actor and or development actor that's that to work hand in hand with state actors, because yeah, I mean, otherwise, you know, there's I think that just doesn't really make sense. So in that sense, we did conduct some like trainings and sessions where we, at the end, the goal was to derive and do the analysis of cropland abandonment in hard-to-reach areas from Sentinel-2 imagery in different places at different times. And now it's operational, and like there's a group, like a working group in each country where we went and kind of like spoke about this script, because it was based on the Google Earth Engine script. And I think so there was also this this need to bring yeah, like JavaScript into the discussion, and how like this is used, and do some kind of like, yeah, I would say like explanation of like what Sentinel-2, also Sentinel-1. There was some discussion around this different technology. I can mostly speak about this data itself, because this is the data set that the whole of the analysis is based on. But I'm sure it's the same, like, you know, it would be the same if it was from NASA or another provider. But yeah, as far as I can speak, it's mostly with the Copernicus products. And I think there's a great potential for it, because it's global, because it's granular, because it's like every 6 days, speaking for Sentinel-2. So the potential is great, and there's a big interest. So yeah, hopefully everyone is gonna keep going with that move.
All
Yeah,
right.
that's it. I hope I answered the question.
Yeah, you did. Stephen, do you want to go next, please?
Yeah, sure thing. Thanks. Thank you, Mustafa, for that question. When it comes to adoption, I always feel like that we should adopt the bottom-up approach, so that you can we will be in a position to make sure that the solutions that we develop are always being consumed by the end users. When we talk about the bottom-up approach, we're talking about involving, in this case, let me talk about the farmers, involving the farmers in every step of creating the solution. So first of all, need to use the design thinking approaches. You know, visit these farmers, try to understand their pain points, try to understand what is happening in their lives. I mean, when you know that, it becomes very easy, because let's say you go to a certain area, then you talk to a farmer, and the farmer says, you know what, I really don't want to invest a lot in this farm, because, you know, we are having issues with climate variability. We've been having droughts, we've been having this. The moment the farmer starts saying that, and the moment the farmer says that, you know, in this area, that is what we experience, you already know, you already have in your head the kind of solution that probably you would give it to them. So you think about, oh, okay, so these people are talking about climate variability. So what can we do? Okay, what we can do is, can we create like crop yield prediction models? These crop yield prediction models will give us data that can be able to help us create maybe an index-based insurance product, or we can be able to have these deal able to make us create, you know, loan products for farmers for their financial inclusion. So the moment you understand their pain points, it becomes very easy. So you go back, you develop the solution, you take it back to the farmers, you listen to their feedback, then you iterate. At the end of the day, the adoption of the solutions that you're giving them will be very high, rather than, you know, using the classical approach, or what actually maybe some people use is, you create a solution, then you try and look for the problem. No, I think the other way around of just trying to integrate all the key players and stakeholders in trying to understand the key issues that are facing them becomes very easy for you now to create a solution, and the adoption will be high. So, and another thing probably would be to increase data and technology literacy, because that is one thing that hinders the adoption of these solutions. Because if people do not understand exactly what is happening, then they'll be very skeptical in trying to use the kind of solutions that you are trying to give it to them. Yeah, thank you.
Thank you very much. So I think we can go into the Q&A section now. We have loads and loads of questions, so I'm sure you guys are ready to give clarification and provide answers to some of them. So let me start from like the basic. The basic is getting data. So I'm going to have to like merge some of these questions together so we don't waste too much time on them. So the first question is, how can people get access to free high resolution satellite data that they can use to analyze crop yield and all of that? Who wants to take this?
If I take this one.
Okay.
Yeah, so one of the major things for the Digital Earth Africa program is to make sure that these Earth observation data sets that we are talking about, especially the ones that can help us to do these monitorings, are actually available for the African continent. So Digital Earth Africa has actually made the provision for everyone to have access to those data sets for free. And currently also we have Planet monthly data set, which the resolution is around 5 meters, also available on our platform, whereby users can actually go there and visualize it. And the interesting about the Planet is also it's a monthly data. So aside having the Sentinel and the Landsat and also the other products that I just talked about, all available, you can also have this one attached to it for you to be able to actually do further analysis on it. Not only are you providing you with the data sets, because at the end of the day, if you get the data sets, you need something to process it out to be able to make meaningful results out of it. We also provide you with the resources. So something like the sandbox, whereby you can actually do in-depth knowledge. And having access to all these things make it easier for everyone to be able to utilize it. So DAfrica is actually providing these data sets for you, the resources. We are building capacity not only for institutions, but also for government agencies, for individuals, for everyone. We have made all the available resources that can actually help users to be able to use the platform available and make use of Earth observation data sets for Africa. So feel free, visit our site, which I think Mustafa organizers can share it with everyone on board to visit the site and see one of all the data sets and the things that are available on the platform.
Yeah, thank you. Yeah, we can pull all that together and share with the audience after the seminar. Rory, Stephen, I think you should take this if you can. Yeah. So someone is asking about the which one is better between multispectral imagery and hyperspectral imagery in terms of the kind of analysis that would need to be done. So do you want to tell them like maybe like the differences between both of them, how they differ basically, and which one is better to make analysis with? I don't know if that's something you can.
I'm trying to see the question. Is it in the Q&A?
Yes.
Well, okay, I can't find it. Can you say again what's the difference? What's the best between multispectral and
hyperspectral imaging? Which one is better?
I think it really depends on the specific application that you have, but from my end to do cropland monitoring, like cropland, I would say just like even areas monitoring, because I was in the sense that we are trying to detect if there was a decline in areas, but so that was enough to use like the NDVI. So this is actually just looking at red and near infrared bands of a classic optical image. So in that sense, that was pretty basic, but it contains so much information in itself. Then I think if your application is to actually go into agricultural precision agriculture, maybe like really go into details and like what is the type of crops, is it mixed crops, is it like single crops? So those all different kind of levels of information that you want to have on in terms of agriculture, then you might want to go into like different spectral resolutions. So I don't know if we can say that, you know, there is one that's better than the other. It also depends on the data you have access to, on what you, yeah, I think the application, the precise application is gonna define what data you want to use. Like I wouldn't be able to tell you what's better. I think they're both really good at depending on what you want to do. So
Okay.
yeah, there's a lot, like there's an actual work that everybody has to do before rushing into the data and like trying to is to really understand what we're trying to detect. And then trying to, you know, like look into research publication, asking people who like have worked on this to understand what's possible, what kind of data is out there, is available, and what can be done, and then test different options, and then see what gives you the results that you're working. Like, I don't know, I'm just speaking from my kind of operational research experience. Like, yeah, this is what I would answer for that question.
All right, thank you. Stephen, I want to throw this to you. So someone is asking if there are like APIs that they could use to analyze some of this data. So if they get the free data, are there like free APIs out there that can be used to make those analyses?
Okay, thank you. Thank you so much. When it comes to APIs, it's also dependent because when you look at the different cloud computing platforms that you use at the moment, first we have Google Earth Engine, which is mostly used at the moment. We also have Planetary Computer. So it depends on the kind of, you know, use case that you want to use the data for. But also you can be able to develop your own APIs using, you know, different, you know, backend applications because you have access to the data. You're able to get this data directly from Google Earth Engine, also through an API. Then you can be able now to create your own API with respect to what. For example, if you wanted to do crop monitoring, right? So you'd want to get data probably on a 2-weekly basis, on a fortnight. So you create an API that pulls the data from Google Earth Engine, or even Digital Earth Africa. I think Edward talked about it and said that there is a way in which, you know, there is a gateway, I think an API gateway that, you know, enables people to plug into the data. So I think even Edward can talk about this a bit more, but I believe that if you want this data, yes, you can even, you know, develop these APIs, then you can be able to have it on mobile applications. Yeah.
All right, thank you.
And maybe Edward can say something about that. Yeah.
Yeah.
Yes. So with APIs also, they are very very crucial, especially for developers and for users who wants to have it in other platforms. Right from the beginning, I made mention of a user in Kenya who was actually informing farmers for them to be able to know the rainfall pattern within their area, and they use the API that Digital Earth Africa actually provides. So there are APIs that we have for all the products on the platform, and we also have the OWS services. So it's another way of, maybe if you want to connect it to your ArcGIS or your QGIS, you have all those APIs available for you to connect to it. And if you are building your own web application, either for mobile phone or for laptop also, the APIs are available for you to have access to.
All right, thank you. This is also directed to you, so I'll just have you take it before we go to another speaker. So when you were discussing the other time, you mentioned the fact that you also do capacity development programs that are targeted towards institutions and governments. So there's a question here that is asking whether you also collaborate with universities in Africa. So I think the question is like, are you open to like any university in Africa that are doing some courses that are related to GIS or remote sensing or stuff like that they could come and you guys can partner and maybe train them on how to use some of these tools? Is there something that you do currently at Digital Health Africa?
Yes, yes, we collaborate with universities across the Africa country. So we are open to it. Currently, we have universities in Ghana, Kenya, Rwanda, Tunisia, a lot of universities across, whereby we are training them to be able to make use of the platform and also utilize it within their research. And so Digital Health Africa is actually open for it. And if you want us to have a collaboration with the university, you can kindly reach out to us, and we're happy to be there to train them, for them to be able to take advantage of this platform.
Okay, so this is the question. I'll just throw it open to any of the speakers that is willing to take this. This is regarding what, like the status of early warning systems in Africa. So instead of talking about what we do after there's an issue, there's a question here that is actually talking about what the status is in different African regions regarding early warning system. So I don't know if anyone wants to take this. Is there anyone that wants to take this? Okay, so let me move into another question. So somebody's asking like, what's the average size? I think this also depends on the kind of analysis that the person is trying to do. But let me just throw it open. If you have any critical insight that you can give to this person. Person asking for the average size of the area of study when using satellite images to produce better and reliable results. Is there like a limit, or is there like a particular size limit that you should work with if you want like reliable results?
I can take this one from, if you want.
Yeah.
I think that's an interesting question, because we were actually wondering ourselves when we walked on this cropland abandonment stuff. First, it was very localized. It was for the testing, like I would say, yeah, 15 villages. Then we kind of scaled up to 100, and then we said, okay, that actually would be interesting to look at a region. So that remains still acceptable in terms of size. I would say this is pretty common. If you look at research papers, usually the area, like the study site, is like the region or the department, like admin 1 level, or sometimes can be admin 2 of a country. It rarely, like, it can be for the whole country, but then for us in our case, what was really challenging is that we kept being asked to analyze a wider area. I was like, okay, that's fine. Now we want to know what's happening in the other region, and then other countries are like what about we also have like hard to reach areas where we have very little information. Like, can we also expand the analysis? And then we're like limited resources. So yeah, I think it would be hard to answer that there is an average size of area of study. In some cases, like when there is applicability to a whole region. Again, the case for us, it was at the end 7 countries of the Sahel, and so that was way bigger than what we expected in the beginning, or what is the average size of an area of study that we usually see in publications. So that was really part of the challenge, to actually scale up to very large areas. And in the end, I remember, I think it was something like, can't remember, but it was in millions of square meters of kilometers, square kilometers. It was massive. And so yeah, I have to find again, like I could maybe share if someone are interested, of the like regional overview of like the 7 countries analyzed. Not all areas in the country, but it was all the hard to reach areas, and it was like huge. I would have never thought that we would manage to study such a wide area. But I think by implementing and incrementally adding up to the automatization, of the analysis, then at the end you manage to. But yeah, for the test part, you don't need very large areas, I would say. It's better to focus on an area where you can also get some validation from the field, or it's better to focus and then expand rather than say okay, I'm gonna work on the entire continent or something. So that's my experience on that one. Merci.
All right, thank you very much. So Edward and Stephen, do you have any final words that you want to tell our audience?
Yes, so for the food security issues in Africa, it's not just a one institution that can actually solve it. We need policymakers and stakeholders. They have to actually work together to create an integrated approach to these food insecurity issues that we have across the continent. And it actually involves a lot of collaborations between government, international organizations, private sectors, NGOs, and also the communities that are on the ground. And so we need effective collaboration, and that can actually lead to development and implementation of policies that promote sustainable and equitable access to food across African countries. So one of the things that I always be saying, and I'm actually proud of the Africa program, is we try to work with partners across Africa and also government agencies to understand the local context of the regions. And through that, we build their capacity for them to be able to utilize the platform for problems such as the food insecurity that we are talking about within the regions that they are working with. So it's a collaborative effort, and all the data sets and everything that we are having right now that we are in the data era, we can actually achieve our goal if we work together on it. Thank you.
Thank you very much for that. Stephen, do you also have some final words for our audience?
Yes. I work for Amini AI. Amini AI is is a startup that is trying to bridge the gap of data in Africa. So we are creating a platform that ingests data from different sources, be it satellite data, drone data, and fusing it with the ground truth data to come up with analytics and insights at the end of the day. So what I can say is that one of the things that we can do in this Earth observation space is partnerships. I believe in the strength of partnerships to be able to compete each other. Because yes, we are here. We are creating. We are creating a platform that ingests data, right? But we cannot also be in another area to collect ground truth data and all. So we really depend on partnerships so that we are able, to bring the best out of observation data on the agricultural spectrum and landscape. And another thing, probably a parting shot, is having been in this sector, I think now for 7 years, one of the things that we're still grappling with is data in the agriculture sector, training data or ground truth data. That is where we're still grappling. We're talking about crop yield data. We're talking about crop type data. Talking about regenerative agricultural practices data. Talking about things to do with crop rotation, crop residue, all those. At the moment, we are trying to urge farmers and stakeholders to go back to regenerative agriculture practices, but you also want to map out, these practices so that we are able to, create policies, interventions that are able to take people back to regenerative agriculture practices, so that, of course, in the space of climate change, we're able to sequester more carbon. So collection of this is where the biggest opportunity is in the Earth observation. So if anybody out there is listening, concentrate on data collection in the agriculture spectrum, and let's create partnerships so that we are able to bring out the best. We've talked about so many things, but if we were given like 5 hours or 10 hours, we would have delved in, deep dive into what the power of Earth observation can bring into the agriculture sector. So thank you so much. And if probably yeah, you will get our contacts, you know, in the I think LinkedIn or whichever place, so that we can be able to communicate more about, you know, some of these solutions. Thank you.
Thank you very much. So let me start from here. We've all heard from our speakers, and just like Stephen rightly mentioned, if we had more time, perhaps we would have taken more questions than we were able to today. So one thing I would like to tell all the attendees is, if you have any more questions, or if you need clarification on anything, or if you are open to like collaborating with any of them on any kind of initiative or program, kindly reach out to them on LinkedIn. They are very active and they would respond to you. I promise you that. So on that note, I would like to say a very big thank you to everyone that has joined in on today's program. Thank you for giving us your time, and I hope that you've been able to learn a few things about the current landscape regarding food security in Africa, what we need to do to get to move to like the next stage, and how we are actually doing that in the continent. So again, till we meet the next time. So for newcomers that are not familiar with the way we run this program, we usually have a webinar every month, and each webinar is going to tackle a different problem within the African context, looking at how space technologies, whether EO, whether SATCOM, whether GNSS, can help solve that. So just look forward to our next webinar in August, and we hope to host you on various other segments of this particular discussion. So thank you very much, everyone, and enjoy the rest of your day.